In this video, we're going to talk about systems of linear equations. Linear is kind of an important idea because we will not be discussing, at least at this moment, systems of quadratic equations or nonlinear equations. So we're going to talk about systems of linear equations, and the first thing we should identify would be what are the solutions to systems of equations? And they are values for variables that are solutions of each equation in the system. So our values for x and y, and possibly also z if we have three variables, our values will satisfy each and every equation that exists in the system. So we're going to start by actually verifying that the values that I'm giving you, which are here, this ordered pair 2, -1, and this ordered pair 1, -1, 2, for the second problem, we're going to verify that these values of the variables listed are solutions of the system that I'm giving you. So again, it's important to note that this is my x value and this is my y value. And what we will do is now simply substitute and do our order of operations to see, in fact, if it makes it a true equation. So 2 times 2 minus -1 equals 5, which is 4 plus 1 equals 5, which does in fact check out. We'll do the same with the second equation. So 5 times 2 plus 2 times -1 equals 8. So this will be 10 minus 2 equals 8, which does in fact verify. So 2, -1 is a solution to our system of equations here for problem number 1. For the second problem, you'll notice I have 3 equations with 3 variables. The first variable is x, then y, and then z. And in our ordered triple, z is always represented as the third value. So again, let's substitute these in for each equation and verify that in fact they make true statements. So 3 times 1 plus 3 times -1 plus 2 times 2 is equal to 4, which makes this 3 minus 3 plus 4 is equal to 4, and that does in fact check out. I then have 1 minus a -1 minus a 2 is equal to 0. And so this equals 2 minus 2 equals 0. Again, that also checks out. And finally, for the last equation, I have 2 times -1 minus 3 times 2 is equal to 8. So this will be -2 minus 6 is equal to +8. So this, in fact, does not check out. So therefore, this is not a solution to this system of equations. You might recall, substitution means you're going to substitute one quantity or one thing for another thing as long as those things are of equal value. So right now, we need to take one of these equations and we need to solve it for a variable. And it really doesn't matter which equation, and it doesn't matter which variable. So pick the easiest possible one. So I'm going to pick equation number 1, and I'm going to pick y as my variable because there's no coefficient, or the coefficient in fact is 1, so it makes it easier to work with. So here's what I have. I have 5x minus y is equal to 21. Subtract 5x to both sides. I have -y is equal to -5x plus 21, and divide both sides by -1. So I then have y equals 5x minus 21. So at this point, what we're going to do is take the second equation that we did not solve. So that would be 2x plus 3. And we're going to leave a blank or an empty spot where the y happens to be. And the reason we're choosing y is because we solved the other equation for y. And we will then substitute or replace the y with this expression 5x minus 21. So this is now 5x minus 21 in place of the y. And what this now gives us is an equation that's all in one variable, which we can solve. So we now can do the distributive property to get 2x plus 15x minus 63 is equal to negative 12. Combine the x terms, so you have 17x minus 63 is equal to 12, negative 12, sorry. Add 63 to both sides. And so what we have here is 17x is equal to 51, and divide by 17, and you have x is equal to 3. So this produces 1/2 of the solution. Now remember, you're looking at two values. You're looking at a value for x and also y, so don't forget that. You have 3 options on where you can substitute this value for x to get y. You can go back to the original number 1 equation, the original number 2 equation, or you can go to the solved number 1 equation. I'll call this equation 3. So you can go back to number 1, number 2, or number 3 to find the y value. Honestly, number 3 tends to be the easiest, but I'm just gonna go ahead and pick one. I'm gonna pick number 1. So I will take 5 times 3 minus y is equal to 21. That's 15 minus y is equal to 21. Subtract 15 to both sides. So you have negative y is equal to positive 6, so y must be equal to negative 6. So your answer, and it really is an ordered pair, so I really encourage you to write it as an ordered pair, is going to be 3, negative 6. That is the point at which the two lines that are represented by these two equations intersect. The second method for solving systems of equations is using a process called elimination. And elimination means just that. You're going to eliminate a variable. So if you look at this, you need to decide which variable to eliminate. And to kind of look at it, you need to think in terms of your coefficients. I have a 3 and a 5 here. I've got a 6 and a 4 here. I'm going to go ahead and choose the 4 and the 6 simply because they're already of opposite signs. So I can add to eliminate them, which to me is a little bit easier. But notice how if I were to add them right now, 4 plus negative 6, I'm not going to get 0. They will not eliminate. So what I must do, first I'm going to erase all my work, what I must do is multiply each equation by something, by some value, some scalar value to get them to be the same. So think in terms of like what you would do for a common denominator. I'm going to multiply the first equation by 3 and the second equation by 2, which will produce this new system of 15x plus 12y equals 3, and 6x minus 12y is equal to 4. Now I have a system of equations where I have both 12s, and since they're opposite, I can add to eliminate. So again, your goal here is to do a 12y minus a 12y so they cancel out and you get 0. 15x plus 6x is 21x, equal to 3 plus 4 is 7. I am then going to go ahead and solve this, so divide by 21, and I get x is equal to 1/3. I do want to keep this in terms of a fraction. I do not want to convert this into a decimal because then you'll round, and by rounding it's inaccurate. All right, now once I have this, I'm going to go ahead and substitute this into either equation. It doesn't really matter. I'm going to choose the second one because I view this one as a possibly slightly easier one to do because of the fact that it's 3x, and I recognize the fact that 3 times 1/3 is a little easier to do than 5 times 1/3. So I will have 3 times 1/3 minus 6y is equal to 2. This will produce 1 minus 6y is equal to 2. Subtract 1 to both sides. Negative 6y is equal to 1, which means you divide by negative 6 to both sides. And so y is equal to negative 1/6. Now again, we do want to represent our solution as an ordered pair because it is actually a point where these two lines that are represented by these equations intersect. So it's 1/3, negative 1/6. So that is my solution to this particular system.